All right, so for today, we wrote a programming assignment, and then I also told you I'd introduce GitHub to you today, right? And we did not use GitHub last semester. Is that an accurate statement? Okay, got it. All right, so we're going to write a Java program that defines a string variable and then creates a loop that goes through every character in the string. And it's got to count the number of vowels it finds. So every single time it sees a vowel, we need to count whether or not it was a vowel. All right, so let's take this one step at a time. And we said for testing purposes, your string should hold the name of a Bible book in the New Testament. Okay, so we're going to define a string variable. We're going to fill it with Matthew as a starting point. And we're going to go through a loop that's going to go through every character of that string. Let's just start with that. Step one. All right, so we'll go over to Eclipse. And I'm just going to work inside of driver here. So we'll say string s is equal to Matthew. Then we're going to go ahead and write a loop that goes through every element of this string. For int I is equal to 0, I is less than s dot length, I plus plus. There are s dot length number of elements inside of s, chars inside of s. And we'll just prove that we're getting each of those by saying we'll print out s dot char at I. Okay, so that's going to go through every character in S and print it out to the screen, proving that we're moving through that string correctly. All right, so there's our output from our characters in the string. All right, well, now we're going to go ahead and we're going to write a little helper function. So it's going to be outside of the main method, but inside of the class. So we're going to write something that helps us detect whether something is a vowel or not. Okay, so it's going to return true if it's a vowel, false if it's not. So it's going to be static Boolean is val. This guy will take a char as a parameter, and it should return true if that char is one of the vowels. All right, so we can go ahead. Well, let's do this super verbosely first, and then we'll start paring it down. That way you're getting to see quite a bit of Java syntax while we're going about it. Sound good? So first we're going to ask a question. So we go back to what do all programming languages do for us? They allow us to remember stuff, ask questions, repetition. All right. We know that the vowels are A, E, I, O, and U in upper and lower case. So we could be super verbose here and literally ask every question. If C is equivalent to lowercase a, return true. Else, if C is equivalent to lowercase e, return true. Else if C is equal to I, else if it's equal to O, else if it's equal to U, else if it's equal to capital A, else if it's equal to uppercase E, uppercase I, uppercase O, uppercase U, else return false. So function's name is this val. It's going to take a char in as a parameter, and we're just going to ask a bunch of questions. Is the char you handed me, is it an A? Is it an E? Is it an I? If it's an A, return true, and we're done, because return makes a method immediately end. If it's not, let's check the next one. Is it an E? Yes or no? IOU, AEIOU, so upper and lowercase version. If I've checked everything and I didn't find any matches, go ahead and return false. So now I have a tool that will tell me, is the character that I'm currently looking at a vowel? And what's my job here as I go through my string? I'm to count the number of vowels I ran into, right? So that means we're going to need another variable. We're going to have to remember something else. We're going to say int count. We'll start off at 0. We haven't found any vowels yet. We're going to take our current character we're looking at. We're going to ask a question about it. If is val, and I'll pass it the vowel we're checking. So if this character, that guy boils down to a character, if is val returns true for that, if you really want to see it, we can put true in there, even though it's redundant. We're asking is true true. Okay. So if the value that gets returned from this is equivalent to true, that means it's a val. You actually do not need this part of it, because if it's equivalent to true, this thing right here would boil down to true, which is true. All right. So if it is a val, then we'll go ahead and say count plus plus. If it's not a val, we don't care. We're not going to increment our counter. We just move on to the next character. In the end, we'll go ahead and do a system.out.println count. And there is our 2, since there are 2 vowels in the string Matthew. All right, that makes some sense? So let's call this guy isVal1 for version 1 of our isVal. Now let's write this a different way. So we're going to give ourselves a couple different versions of isVal here. We'll say static boolean isVal2. We'll also take in a char c. And now what we're going to do is we're going to use that collection of ands and ors and things like that to ultimately return the value. So we're going to say return c equal to a, or c equal to e, or c equal to I, O, U, and actually what I'll do is steal all those. A, E, I, O, and U. All right, so this will return whether C is equal to any of these. Remember, an OR returns true if at least one element is true. In our case, it can only be one of those. But if all of those are false, then the OR will be false. So this is another version of isVal2, or another version of isVal. So we'll call this guy isVal2, and we see we get the same output. All right, so this guy performs the same action. Functionally, it's identical, but we can say this is a little bit less verbose. We're not like wrapping it all inside of if statements. Now, does that mean that this one is necessarily better than the other one? Pick the one that you understand the best. Now, I would say that professional programmers probably would not write it this way. It's a little bit too verbose, but certainly when you're a beginning programmer, this is reasonable. And even a professional programmer, if you write it like this, anybody can read your code, right? One thing you run into is people will write code that nobody else can read, and or even yourself, you don't know what you wrote 8 months ago or something like that. So we can say that this is extremely clear what it's asking. If this is true, do this. If this is true, do this. If this is true, do this. This one's maybe a little bit more complex in that we have to know what the ORs are doing. So if it's any of these things, if any one of those is true, return true. Otherwise, return false. All right, questions about either of those potential implementations for this? All right, so let's go ahead and let me introduce, I think I told you specifically for this assignment, you were not allowed to use the index of method. So index of, I'm going to show you the index of version of this now, okay, that you can see would have made life a little easier. If you remember in Python, we had a function called find. And what find did is it returned the index of the first occurrence of an element inside of a collection, string, list, something like that, or a -1 if it was not found. So the equivalent to that in Java strings is something called index of. So I'm going to call this static Boolean is val, and I'll flag it as index of. This will take in a char c as a parameter. And what I'm going to do is I'm going to go ahead and I'm going to create a string. I'll put it inside of a variable. So we'll have a string called vals. And we have all of our vals in there. And then we'll go ahead and return vals dot index of c not equal to -1. So when I look for the index of c inside of my string vals, if it gives me something other than a -1, that means it found this character inside of my vals. So if this boils down to a 4, for instance, it found it at bucket 4. This is bucket 0, 1, 2, 3, 4. Found it right there. 4 is not equal to -1. That's a true statement that 4 and -1 are different values. So it returned true because that value was a val. All right, so this is the same thing written using index of. You see we still get a 2. And you didn't even need to store this in a variable because we just used it one time, right? So the rule of thumb would be if we're going to remember something, it's because we're probably going to use it more than once. So nothing actually keeps us from just doing that. Because ultimately, when we had vals.index of in there, vals was a placeholder. At runtime, that vals got resolved to its value, which is what we're looking at right here. This was the value of vals. And since we're not using it a second or third or fourth time inside there, we didn't need to put it in a variable. Does that mean it's wrong to put it in a variable? No, in fact, you can maybe even make the argument that it's better to have gone ahead and put it in this variable because at least now we're kind of labeling what this random collection of characters are. You know, maybe most of us would glance at that and say, oh, that looks like the vals to me. Okay, but maybe you're tired, maybe your mind just is going in a different direction. If you have it stuck in a variable that labels it as vals, and then we look at it and say, oh yeah, those are the vals. So I would say that from a best practices perspective, this is probably the correct way of writing this method. But ultimately, as long as it gets the job done, we're going to call it pretty good. One of the things we're going to be talking about in this course is some searching and sorting algorithms that do have some different performance ramifications to them. So sometimes we do need to really consider the efficiency of what we're writing. It could be important, right? But one of the things that we can rely on as a modern day technologist is our computers are fast, right? So we don't need to kind of go out of our way to write super efficient code or something like that. We'd rather have working code first. And then if there's something we just see that looks really sketch about it, we can go and make it a little cleaner or faster or something like that. But a very, very, very high majority of the time, really anything outside of like video games, it's not going to matter if you write it in the most inefficient way possible. Your computer is going to make you look great because it's so fast. Make some sense? So always write code that you understand. Over time, once you become a better and better programmer, you'll start maybe writing it in a little bit closer to best practices or something like that. But don't try to copy somebody else who's writing something a certain way that makes sense to them when it maybe doesn't make sense to you. Good example of that might be this guy right here. If chaining all these Boolean expressions together with ORs just isn't quite clicking for you yet, don't write it that way. Write it the way that does make sense to you. Give yourself your pattern of your problem solving. All right, questions about this? Go ahead.
So is the index equal to the bucket of which the thing you're searching for is, or is it just equal to 1?
Well, it'll be the bucket. So let's say I'm looking for a, let's say I'm looking for an A. If I say, let me just steal my vowels right here. If I say system.out.println vals.index of A, it will find an A at a bucket 0. So that's what it'll print out, is it'll print out that 0. If I'm looking for a capital A, it'll find that at what? 0, 1, 2, 3, 4, 5, at bucket 5. That's where it first found a capital A. But if I put in an R, that is something that's not found in this string, that's where I get the -1. All right, and that's really the superpower. That -1 is the powerful aspect of that, because a lot of times it's easy to say, well, where does something live inside this string? That might not be all that useful to you most of the time, but you might be very interested in whether something is not found in a collection, because maybe you do something different. Like in our case here, what we really cared about is we had a char, we wanted to know if it was found in that collection, which means that it's not found. All right, and that's the logic that we wrote. We didn't care where it was in there. We didn't care if it was found in bucket 0 or bucket 4. All we cared about it is that it was not found. It was not found at bucket -1, which means it wasn't in there. Make sense? Go ahead.
So when you find out the count function, what would be the equivalent of that in Java?
In which function?
The count function instead of the find function.
Which function is it? How do you spell it?
So if you count like the number of A's,
Length. Oh, you mean count. So if you want to write, so like how many T's are in Matthew? I don't think there is one built into Java for that, but no big deal. You just come down here and you say static int count chars in string, or if you want to call it count just so it matches your Python example, this guy will take in a char C and a string S as a parameter, and you'll say int count is equal to 0, and you're going to go through every character in S. And you're going to say if s dot char at I is equivalent to the character you passed in, count plus plus. In the end, return count. So now you have a count function. So now we can go and we can say something like count the number of C's, or number of T's, let's say, in S, and this should give us 2. So 2. If I want to count the number of E's in there, it gives me 1. If I want to count the number of W's, it's going to give me 1. If I want to count the number of R's, it'll give me 0. Yeah, so a lot of times when you have a tool that you want and it's not available, so like for instance, you're saying, well, there's another language that I'm used to having a certain tool that does something. How do you do that in here? Well, if it's not obviously readily available, like either you don't know it off the top of your head or like a very quick Google search doesn't reveal that it's in there, just write it real quick. Something like this. This is good practice, and you see the power of a programming language where you can just say, I want to be able to count the number of characters in a string. No problem. Just write the little function that does it. Now you can count the number of characters in a string all day long. Make some sense? All right. So let's talk about GitHub then. And then we'll look at it through an example. All right. So GitHub, there's really two separate things we're talking about here. Git is a technology that is a repository of all, let's say, that keeps track of, that keeps in a repository all of the changes that have ever happened. If we think about this from a programming perspective, now we're not even talking about GitHub yet. GitHub is a place to put Git repositories. But by default, Git runs on your local computer, and GitHub, and what it does is it creates a folder, which we'll call a repository. And anytime you make changes to something in that folder, it keeps track of those changes. So if we think about this from a computer programming perspective, let's say you're working on your homework assignment, and you've made some, you've done your assignment, you've put it into this folder, and now you're done. And let's say that the next homework assignment builds on the current homework assignment. You might go in and keep working on the same project, right? Making some changes to it and stuff like that. But you might be interested in looking at both versions, having the two different versions or what things you changed available to you. Git keeps track of all those things that have changed for you in the event that you want to look at them. Now, this is especially good in a situation where you are working in like a team of developers, where you're all sharing the same repository, and maybe I add one function, maybe you add a different function. Okay, so now we've both made changes to the repository. Make sense? Now, realistically, we're probably not working on the same local file system. If you were like a little bit more old school, you might be sitting in an office that has like a server somewhere that's sharing like a Z drive, and that Z drive is where the folder lives, where your repository is. And Git would govern that so that when I made changes and he made changes, it would keep track of those changes in that folder, so that if we had to roll back, if he introduced a bug, we could roll back to the previous state of it or something like that. Where it becomes more useful is in cloud collaboration type situations where you and I are working on the same project. We've both checked out the current state of the repository from the cloud. I'm working on my local folder of it. You're working on your local folder of it. I add method A, you add method B. We both are happy with the workings of our two methods. Now, maybe our methods have something in common with each other. Maybe they're reliant on each other, but let's just say they're two completely separate features, but they're features that both belong in the final application. So when I'm done and I check my code into Git, and then I push it back to the cloud, and he's done and he checks his code into his local Git, which doesn't know about the code I added, and he pushes it back to the cloud. Now the cloud has the current state of the project. So the next time here I sit down at our computer to work on our stuff, we would want to do a poll to get the current state of the project, which would then mean that I get his function and he would get my function next time we sat down. All right. But the real key to Git is that it keeps track of those changes in the event that my code broke his, maybe my code breaks the project if his code is active, something like that. So we'd be able to roll back into the last state when the project worked. Okay, so we're going to say that Git in collaboration with GitHub are great tools for software engineering type of situations where you're working in a collaborative group. Now, where it's beneficial for us in here, we're not really going to be using it for that purpose, even though we will get the benefit of that purpose, because I'm going to start using GitHub in class, which means when I do these little code changes and stuff like that, and then I delete everything and do some more code changes, you would be able to go into GitHub and roll back and see, oh, well, what was the example he gave before this example? And you'd be able to look at an older version of that file on there. So GitHub kind of has that advantage. All right. Also, where it's going to have an advantage for us is we're going to pretty quickly have our programs living in 2, 3, 4, 10 different files, which becomes a little bit unwieldy, where with GitHub, you can push the entire collection up to the GitHub website. So with Git, you can push the whole collection up to the GitHub website, and I can then, when I go to grade it, I can just click on the code and you'll give me a link to your code, and I'd be able to see your 10 different files, and I can click on each one and look at them rather than having to deal with screenshots and stuff like that. All right, so good way for collaboration. It's an industry standard tool. Most industries will that rely on software development will use GitHub or something similar to GitHub. Okay, so let's start off by going to GitHub's website. So if we go to github.com, I actually think it's github.com/desktop. All right. Because we're going to use the kind of the easier version of this. It's desktop.github.com. So desktop.github.com, because GitHub is actually, well, if you have a Mac, Git is already installed on it. You can also do Git and GitHub from the command line even after you install it, but it's not that friendly. Not that we shouldn't necessarily know how to do that, because you might be in at a job where you do need to be able to work with Git and GitHub from the command line, where maybe I come out here and opened up my Ubuntu. The problem having terminals and multiple OSs on here. So for instance, I have the Git command from the command line here that I can use for checking things out, cloning stuff from a website. Let me kind of show you that. If I go to GitHub, and let's just do a search for, I don't know, let's do a search for dice roller. All right, well, it doesn't matter which one of these we're looking at. So here's somebody's application for a dice roller. And let's just say I want to get this on my computer. Now, I can go ahead and, so notice here, I can open with GitHub Desktop, or I can download a zip. We're going to be using the GitHub Desktop for our stuff, but historically, before they made it nice and graphical, I would have come out here and I would have said, let me just make a directory here called temp. And I would have said git clone, and then I give it the link to where that's at, and it would have downloaded those files. So now I have that whole project locally on my computer. And if I make changes to it, those changes, right now it's linked to the project that's up there, which I probably don't have permission. This is probably somebody who wrote this project who didn't specifically give me, a stranger, access to make changes to their code. So if I do want to make changes to their code, but not directly to their code, but instead I want to make changes to like my version of their code, I would need to first make a copy of their project under my account. And these aren't necessarily things that you would do that often. Although what I'm about to do, you probably would do, because there's going to be plenty of examples when I give you kind of a starting point for a homework assignment. And you might want to use my starting point to get going, but you also want to be able to make changes and ultimately push your changes back up to the cloud. So in order to do that, let's say I'm interested in this project. Here, is it? I need to log into my GitHub account. And of course, it emails me to a code. Okay. Oh, this is actually reminds me of something. So since you have a cuw.edu email address, as a, so I mentioned earlier that GitHub is an industry standard tool. So one thing that they want is they want all of you to be used to using GitHub, so that when you go into businesses that maybe aren't currently using that, you can convince them to pay for it, is the idea here. So GitHub allows two different types of projects. It's completely free for public repositories, where you are basically sharing your code open source with the rest of the world. They don't charge you a dime for that. Now, having said that, let's say you're working on a video game with a team, with some of your friends or something like that, or it's a small startup company working on a game. Well, chances are that's a product that they're going to turn around and want to sell. So maybe they don't want their code available to everybody, but they do want to benefit from the Git and the GitHub technology for managing their project and changes and things like that. So in that case, you would create what's called a private repository. Only difference is that only the people you've set up as collaborators can access it and work with the code. All right, but that costs like $7 a month per private repository. Okay, now as a cuw.edu, as an education student, you get that feature for free. It's probably on a 2-year rolling basis or something like that. Let's see if what happens to the thing. So see, it says if you're no longer eligible for the education thing, you may update your payment information or downgrade your account. So let's just go ahead. I'm going to click reapply. So here's all the, we're going to do the student developer account. Yes, I'm a student. They need to verify I'm a student. So they say, go to GitHub Education, select the thing that's the best thing, represents you, make sure you choose the email address, and then you, they might ask for proof of your academic status. Probably if you put a Gmail, they will. If you put a cuw.edu, I'm guessing they would not do that. So if I go to GitHub Education here, and I say, let's say get benefits, submit your information again. There's my cuw.edu. Submit my information. Oh, it's the classroom development. And this won't make a difference for us in here. So it'll probably just automatically unlock into my account since my email was a .edu email. But regardless, I'm going to make all my repositories public. And I'm actually going to encourage you to do the same. Otherwise, you would have to give me collaboration privileges for every project so I can see your code. But we'll see the example of this today. Now, to make life easier for all of you, and this is the example I'm going to go through today, you want to go to desktop.github.com and you want to download GitHub Desktop and get that installed on your computer. Small little application. Once you've installed it, it's going to open up and it's going to look something like this. All right. So we're going to use this as our starting point whenever we're going to create a project. So I'm actually going to take our homework assignment from today and I'm going to put it in a new project that's governed by GitHub here. Okay. So if you hit the drop down here, let's see, is it in it'll probably ask you the first time. So I'm going to go to this drop down where it says add. I'm going to say create new repository. And we're going to call this guy CSC250 Spring 2021 Program 1. This was the first programming assignment, right? All right. So I'm naming it something pretty verbose there. And you can choose where you want to put it. I happen to choose to put it in my downloads folder inside of a folder called repos for my repositories. You can do it wherever you want. Now I'm going to leave this box that says initialize this repository with a README. I'm going to leave that unchecked because we're not going to utilize that. If you have it checked, it's not going to break anything. You'll just get an extra file that you're not going to put anything in. Nothing for Git Ignore, nothing for license. Git Ignore is used for if you're a video game developer and you're using Unity. So Unity projects, for example, create these huge projects, which you might have written, you may have dropped in, let's say 10 images, created a couple of animations in there, and then maybe written 4 or 5 scripting files. So a relatively small footprint of stuff. But Unity then, when you actually go to build your game, will turn that into like 2 gigabytes of stuff. I'm just making up a number, but a lot more than a little. Okay. So you probably don't want to have to upload 2 gigabytes of stuff to the cloud every single time you make a change to your application. All right. Because Unity generates most of that stuff every single time, you want to ignore some of those auto-created files so they don't get stored with your repository. And only the parts of it that you made changes to get stored. So if you clicked on this Git Ignore, you'll see there's a whole bunch of options in here. So there's one for Android. The one I was referencing is the one for Unity. There's another one for Unreal Engine, which is like the competitor to Unity, so on and so forth. So it would ignore files that are like not important. They're not part of your development. They're part of the base install or something like that. All right. But for us, we're not going to Git Ignore anything. I actually wonder, is Eclipse in here? It does not. Okay. Because Eclipse does actually have kind of a funky directory structure. I thought it might be in there, but so we're not going to ignore anything. And we're also not going to put a specific license on there. It has a whole bunch of the open source license stuff in there, but we're not doing any of that. Just so leave it blank for everything. Just give it a name and make sure you put it somewhere that you can find. All right, so we're going to go ahead and create this repository. All right, and what that's done now is it's created a folder for me on my computer inside my downloads folder, inside the repos folder. All right, so if I come over here and I go to downloads and I go into repos, we now see we have CSC250 Spring 2021 Program 1. I have an empty folder there. Okay. So I'm going to go ahead and close this. So right now, notice it says I have 0 changed files. It's created a repository, but it's just an empty bucket for the moment. So I'm going to go ahead. I'm going to go back to Eclipse. And I'm gonna just highlight all this code from today, just copy it. But in Eclipse, I'm gonna create a new project. I'm gonna create a new Java project. And it's asking me my project name. So we'll call this guy CSC250 program 1. Now for location, uncheck this box that says use default location. Click browse, and you want to browse to the folder that you created, which is CSC250 Spring 2021 Program 1. That's where my repository lives. So I'll go ahead and do that, and then I'll just click open. That's where I wanted to create that, that folder. Make sense? So then go ahead and click, actually I'm gonna go ahead and click, can I just click finish directly? Oh, this is the reason it did it is because I have a new install on my Mac. I had to give it permissions to use my download folder. All right, so this is the part that since I hit next. So you definitely want to hit next here. And the reason for that is this file right here, this create module info Java file. We're not using modules in here. They're kind of like namespaces in other programming languages, but we're not using them, at least not right now. So we're going to uncheck that. So you'll never use a module when we're using Eclipse in here. All right, otherwise it's all good. So we'll just hit finish. And then here is, I'll go ahead and close this guy. So here is that project. It's an empty project right now. Notice here, if I go back to GitHub though, it notices a couple of files have changed. It says, oh, you have this Git Ignore, you have this .project, you have this .class file, nothing that we wrote, but just something that came as part of creating the project from Eclipse. So I'll go ahead and say new class. We'll call this guy driver and hit finish. And then I'm going to go ahead and paste that code in there that I had. That's the code we wrote earlier. All right, we can test it, see that it still works, all that stuff. Then if we go back to Git desktop, notice here it now sees that, oh, you have this new file driver.java you added. All right, so whenever so we're done with our homework, we're ready to turn it in. Okay, or I'm done working on it for right now and I want to make sure I get it up in the cloud because maybe I work on my homework sometimes on my laptop, sometimes on my desktop. All right, so I'm going to go ahead and it asked me for a summary of what I'm doing here. I'm just going to say initial commit. So the cadence is always you commit changes to your local repository, then you push those changes to your GitHub account. So I'll go ahead and say commit to main. Now, the very first time we do this, it's going to say publish repository. Now, the first time you do it, you might have to log into your GitHub account with this. So make sure you create a GitHub account first. It'll ask you for your username and password. After you've done that the first time, it probably won't ask you for that stuff again. So I'm going to go ahead and say publish repository. Now, this is the important piece. So pay extra attention right now. Make sure you uncheck this button that says keep this code private. Otherwise, when you give me the link to go look at your code, I won't be able to see it. As a student account, you're allowed to make private repositories without being charged. So always just uncheck that. Okay. And then I'll just say publish repository. And it's going to go ahead and publish it and put it up on GitHub. So now it's up there. If I go over to the website and I go to github.com, here is my repository just created there. source folder. Here's my Java file. There's the code up on the internet. Now, I'll just demo real quick, just making a quick little change. I go back into the code. I see, oh, I was giving you an example for something you were asking for earlier. That's not really part of our final output. So I'll go ahead and just get rid of those couple of things. So now we're back to just what was the solution to the homework. All right, we can test it again and see that. Okay, we're happy. We'll go back over to Git Desktop. We see that our file has changed. Now we can go ahead and we can put a little note in here what we did. Otherwise, the default just says update driver.java. Okay, but we might want to make a change. You know, we might want to comment this of why we made a change. So change back to solution for homework. And I'll say commit to main. Again, committing it to main just commits it to the repository that lives locally on my computer. If I want to get it to the cloud now, I'll say push origin. And what that'll do is it will overwrite. Well, actually, it just updates to it commits my to the cloud one. So my cloud one will show me the current state of things. So if I come back in here and I refresh, notice that I have the newer version of the code here. But I can also click on history and see I have 2 versions of that file. If I can click on, and I can click on this one, and we see that I have that original stuff in there. So you can go back and look at old things. That makes sense? So then what you would actually submit is a link to your repository. This guy right here. You would submit a link to your repository so that I can get in and see it. So your homework for Wednesday, convert your first programming assignment, or why don't we say load your first programming assignment to GitHub as done in class, and submit a link to your GitHub, or to your code on GitHub. Make sure you make repository public. Make sense? So after next class, I should be able to assume all of you will be able to submit your future homework assignments. All right. So the next class, I'll show you how to fork the code so that you can start with mine as a starting point. Okay. Questions, comments, concerns, bribes? All right. I'll see everybody on Wednesday.